Afternoon, ladies and gentlemen. My name is Blessing Sitabule, and today I'll be presenting to you my PhD work. So I'm a PhD student that is based at the University of the Witwatersrand, and I'll be presenting to you my work that is entitled Developing Machine Learning Models for Predicting Cytochrome P450 Ligand Potency. Firstly, it is important to note that cytochrome P450 enzymes are involved in approximately 90% of clinical drug reactions. As a result, it is important for us to understand how these enzymes interact with drug molecules or any ligands of interest. This is for the purpose of drug discovery, pharmacogenetics, as well as protein engineering. So these, we can perform such studies using computational methods. Therefore, in this study, we aim to use machine learning models to predict the potency of ligands of interest with respect to cytochrome P450 enzymes that are known. Therefore, to achieve our aim, we had to develop several machine learning models based on different algorithms, which are shown here in the middle. So for our input, we used data that was acquired from Binding TP. So that was the data that was used, which includes the cytochrome P450 enzyme assays with ligands of interest. So that was the input data that was used. And then the several algorithms that are used are shown in this section of the diagram, which includes different types of algorithms, such as the neural network, as well as the extreme gradient boost. And then these were then used to then so once we did that, we then evaluated the performance of the models. Here in this slide, I'm showing part of the evaluation methods that we used. This includes accuracy. So as you can see on the bar graph, on the far left, you can see that different methods, different algorithms include extreme gradient boost, which is represented in red, and the other algorithms in the different colors shown on the key. So on the x-axis, that's the different feature reduction methods that we applied to see if that could influence the performance of the model. And then we noted that the red bars, which is the extreme gradient boost method, had the highest accuracy. So the red bars were higher than the other bars, which means the extreme gradient boost algorithm outperformed the other algorithms. And then on the far right, this is the receivable curve, which shows the level of the area under the curve. So here, what the area under the curve score tells us is that how well the model can distinguish between the different potency levels of the drug molecule of interest with respect to the cytochrome P450 enzyme. So in conclusion, we were able to show that the feature reduction methods influence the performance of the machine learning models. And from our results, the extreme gradient boost algorithm was the best performing method. And then machine learning model can be employed to predict the potency of enzyme ligands with respect to the enzyme of interest. And then this has potential for application in drug discovery and pharmacogenetic studies. I would like to acknowledge my institution, my supervisors, funders, as well as the conference for granting me an opportunity to present my work. Thank you.